Hello, let us look at the January of 2015 Regents questions. So here comes the first one. As you can see, in triangle AFGH, and these are the given informations. Now, which statement can be used to determine the numerical value of h? Now, as you can see over here, all of them are resembling law of cosine. So, as you can write down law of cosine over here, notice that these angle C and then side C has to be opposite of the law of cosine. Then h is what we're looking for, and then angle h is given, so h and then cosine of 57 has to be opposite of the equation. And then the rest of them, we can just fill them out as it goes along, as you can see right over here. So in fact, our answer was choice 2. Now let's look at the next question. In the table below can be modeled by which equation? So now what I'm trying to do is I'm trying to see which one of them can match the first value. When I plug in -2, I should be getting 5. So I'm going to try each one of them. When I plug in -2, and will I end up getting 5? No, I didn't for the first one. And then second one, when I plug in -2, okay, in fact, absolute value -2 became 2, so we end up getting 5. So second one seems to be okay. How about the third one? Third one, notice that if I have f of y, that means actually it's equal to x. So y will be plugged in, which is 5 will be plugged in, and I should be able to get -2. Let's see if that will be true or not in this case. And then 5 plus 3 is not equal to -2. The last one, absolute value of 5 plus 3 doesn't equal to -2 either. So therefore, number 2 becomes our answer. Now, number 3 here, we need to basically express the logarithmic equation into the exponential equation. How are we going to do that? We know that log base b of c is equal to a to the c power equal to b. Then, using the same logic, we'll end up getting a to the y power should be equal to x, which is choice 3. Alright, let's look at the next question, number 4. Now, in this case, which expression is equivalent to the sum of the sequences? Now, yes, you can derive the sequence if you want to, but easiest thing which we can do is this. You see the first value was 6. Then, we have to get 6 when I plug in each and every of these initial values. So then, when I plug in 4, will I end up getting the values that I'm looking for here? That's the case, yes, because 2 to the 4th power minus 10 is equal to 6. So first one seems to be okay. How about the second one? And then when I plug in 3, I do end up getting 6 as well. Third one, when I plug in 2, I do end up getting 6 as well. Okay, all 3 of them seems to be nice. And lastly, when I plug in 2, I still end up getting 6. Now, then when I plug in the upper value, I should end up getting the last number, which is 30. So for the first one, when I plug in 7, I should end up getting 30. So 2 to the 7th power minus 10. In fact, it's not equal to 30 because 2 to the 7th power is it'll be 128 minus 10 is not equal to 30. How about the second one? As you can see, 2 times 6 squared divided by 3 is not equal to 30 either. How about the third one? 5 times 5 minus 4 is not equal to 30. In fact, it's 21. On the other hand, lastly, 5 squared plus 5 is in fact equal to 30. So our answer is choice 4. Now, next one is the number 5 here. We have an investment earning 5% interest compounded quarterly. Now, if you see compounded quarterly, that means our formula is this. A is equal to P, which is a principal value. And notice that that's basically what we end up getting. 1 plus R over N. N can be different values, such as if, as you can see here, quarterly, that means N is equal to 4. Monthly, that means N equals 12. Daily, that means N equals 365, so forth and so on. But now, you know that this function is exponential function. So therefore, which one of these 4 looks like an exponential function? It is choice 1. As you can see, number 2 is a linear function. Number 3 is logarithmic function. As an example, it can be y equals log of x, or any other log functions for that matter. Alright, so let's look at the next question. Number 6. Now, real, rational, and unequal. That's right, we are looking at discriminant, b squared minus 4ac. In this case, since the value has to be rational, that means the discriminant has to be perfect square. Now, then we're going to go through choice 1 through 4 and then see which one of them will get us the discriminant of perfect square. So first one is b is 10 and then c is equal to 25. And as you can see, 10 squared minus 4 times 1 times 25 is not a positive perfect square, because in order for our roots to become real, rational, and unequal, it has to be positive perfect square. And then first one becomes 0. Then in that case it would become real, rational, and equal, not unequal. So the next one would have been negative 5 squared minus 4. A is 1, and then c is equal to 4. Once you calculate this one, you will realize that that's equal to 9. A 9 is a positive perfect square, so our answer would have been choice 2. Alright, let's look at the next question here together. Now, that's the function f, those two pieces put together. Now, then is this a function or relation? And some people can call it that will it pass the vertical line test? It does. Or one value of x has only one value of y. Okay, that satisfies here as well. So therefore f seems to be a function. That means choice 2 and choice 3. How about g, which is looks like a step function or step relation, depends on how we look at it. Now, but notice that these 2 points has a 2 y values for one given x value. Over here it continues, so therefore g has to be relation. That means choice 2 becomes the answer. Alright, let's look at number 8. What is the common ratio? How do you find the common ratio? Then we have to divide. So a sub 2 divided by a sub 1. Then we'll end up getting something like this. Second term, which was 3/4, and the first term is negative 1/2. As you divide them, you will realize that the same thing is negative 3/4 multiply 2/1, which is negative 3/2. Choice 1 becomes the answer. Number 9. How many different ways can teams of 4 members? So, since we're talking about teams, we are referring to the combination, not the permutation here. So then, we end up getting 20C4, which is equal to 48/45. Choice 3 becomes the answer. Number 10. Now, sine of A is given, and then we're looking for cosine of 2A. But what do you realize cosine of 2A? Cosine of 2A has 3 identities. In fact, it is all equal to 1, but there's one of them involves only sine, which was 1 minus 2 sine square A. So all we have to do is place 3/8 in place of sine of A. then what do we end up getting? Then it'll be 1 minus 2, 3/8 squared. Then once we calculate them, we'll get over 64. Our final answer becomes 46 over 64, which is equal to 23 over 32. Choice 3. Alright, let's look at the next one. Number 11. When factored completely, so meaning when we have 4 terms, you find it to be quite easy. Not all the time, but many times you can separate them 2 by 2. So here, from the first 2 terms, we realize that x squared was common. So when you factor out x squared, we are left with x minus 2. From the next 2 terms, we can factor out negative 9. Then we get x minus 2 as well. And you can see that x minus 2 are common here. So then we end up getting x minus 2. And the remaining is x squared minus 9. But that's not done yet. So because x minus 2 and x squared minus 9 can be factored into x plus 3 and x minus 3. So choice 2 becomes the answer. Alright, let's look at the next question. Number 12. It's conjugate, that means we are keeping everything as it is, except the sign in the middle will be switched. So we have negative 3 plus 2i. But once you multiply them, this is ends up being difference of squares. So we get 9 minus 4i squared, but I squared is equal to negative 1. So we get 9 plus 4, which is 13. Now, number 13, what do we realize? It's the equation of the circle. So, equation of the circle goes x minus h squared and plus y minus k squared equals r squared. Now, center seems to be negative 4, 2. And then that's the radius, that which we just draw, because coming from the origin. Then using the simple Pythagorean idea here, vertical difference from the center to the origin was 2 and the horizontal difference was 4. Then using the Pythagorean theorem, you can simply see that 2 squared plus 4 squared is equal to r squared. Then 20 is equal to r squared. So then I don't actually have to find out the value of r, because what I'm looking for is r squared, as you can see over here. Now then, our final answer becomes x plus 4 square and the y minus 2 square is equal to 20, which seems to be choice 4. Now, number 14, the fact that we have negative 1 as an exponent, why don't I distribute negative 1 to all 3 factors here? Now, then we get 5 to the second power, negative 2 times negative 1, and this is basically what we end up getting. But as soon as now when you see negative exponents, then you know that it has to be in the different location, from numerator to denominator, or from the denominator to the numerator. In this case, a is in the numerator, so we end up getting 25b to the 4th over a cubed, which is choice 2. Number 15. In this case, something that simplifies to 1 many times, coming from one identity, sine square plus cosine square is equal to 1. Now then, for the first one, as you distribute sine square to both of them, we get sine square x, and then sine square x times cotangent. But what is cotangent? That's a reciprocal of tangent. Since tangent was sine over cosine, cotangent would have been cosine over sine. So we will get cosine square x over sine square x. Then you can see that sines cancels out. So then we have sine square plus cosine square, which is equal to 1, so which is fine. How about the second one? We realize that secant is 1 over cosine square, but 1 minus sine square is in fact cosine square, coming from this identity over here as well. And then you can see the cosines cancels out, so that's equal to 1. Number 3, cosine of x is being multiplied to tangent and 1, but tangent is sine square x over cosine square x, and then as you distribute cosine squared to 1, we end up getting negative cosine squared. Okay, then cosines cancels out, then we end up having sine square minus cosine square. Is sine square minus cosine square equal to 1? No, in fact, it's not. If you want to talk about this some further, you will realize that so the answer is 3, but sine square minus cosine square is something very close to double angle formula for cosine of 2x. In fact, this will be equal to negative cosine of 2x because sines are the opposite of the cosine of double angle formula. Number 16. When we multiply these radicals, given that they have same index of the radical, 3 and 3, it's best for us to multiply them first and then simplify. Then here we have 4 times 16, and a to the 5th power and b to the 6th power. Alright, then we know that 4 to the 3rd power, because 16 is 4 squared, times 4 becomes 4 to the 3rd power. And a to the 5th power, I can rewrite them as a to the 3rd and a squared, and then b to the 3rd times b to the 3rd. Alright, then every perfect cubes can come out of the radicals. So we get 4ab squared, and then that's basically what we end up getting. Number 17. Product. Sum and product, you should know this one. So first I'm going to move 3 over to the other side, so we get 4x squared minus 5x minus 3 equal to 0. But what is the product? That's a c over a. Then simply our answer becomes negative 3 over 4, which is choice 3. Alrighty, let's look at the next question. So how many 11 different letters, different 11 letter arrangements are possible? So from here, then we end up getting, since we have 11 letters, we start with 11 factorial. But now we have to divide by the repeating letter arrangement. So here we have 2 A's, 2 R's, 2 N's, and then 2 E's. So we will be dividing 2 factorials 4 times. So once you put this one into calculator, then you'll end up getting this value. So therefore choice 1 will be the answer. Alright, number 19, third term. In this case, the question is not most well written. When it says in the expansion, what they actually mean is in the expansion, and when combined and arranged by the decreasing order, a decreasing exponent of the x. That's what they're talking about here. So therefore, in that case, the third term means when r is equal to 2 in this formula. As you can see, each expansion of a plus b to the n power can be expressed in this way. Except that r equals 2, because the first term will have r equals 0. Then 5c2, because r is equal to 2, and then 5 was the exponent. And then we get, in place of a, I have 2x. 5 minus 2, and then in place of b, I have negative 3. So as I calculate this one, 5c2 equals 10, and then 2x to the 5 minus 2 power is equal to 8x to the third power, and then we end up getting this value. So when I combine them together, multiply them out, we get 720x to the third power. Alrighty, let's look at the next question. Number 20. Angle theta is in the standard position, and negative 4, 0 is the point on the terminal side of theta. What is the value of secant theta? So here, negative 4, 0 would have been around here. Then, what is my angle? You can see that my measure of the angle is 180 degrees. Then secant theta means 1 over cosine theta. But what is cosine theta when angle is 180 degrees? That's equal to -1. So we end up getting 1 over -1, which is equal to -1. Choice 2 becomes the answer. Alright, so let us look at the number 21. We're looking for domain. That means the denominator, in this case 2 minus x, has to be not only greater than, but it cannot be equal to 0 because of the because it's the denominator of the fraction. So it has to be greater than 0. Then simply 2 minus x has to be greater than 0. Then 2 has to be greater than x. Then that means x has to be less than 2. Choice 2 becomes the answer. Alright, so here what we can do is, when we have a fractional equation, to get rid of the denominators, we will multiply them by the common denominator, x, and then x minus 3. So then we're going to do that to both sides. Then what do we end up getting? From the first fraction, x minus 3 will cancel out, so we have 5 times x. From the second one, x cancels out, and then third one is multiplied in this manner. Then 5x and -2 is distributed to x minus 3. And then x is distributed to x minus 3 as well. Once we have this, we're going to bring everything onto one side. And 5x minus 2x becomes 3x. And subtracting 3x and then subtracting 6 from both sides, then we'll end up getting x squared minus 6x minus 6, which is choice 3. Number 23. How many distinct triangles? So in this case, what we can do is we can use law of sines. Now, then side A over sine of A, which is 30 degrees, is equal to side B, which is 12 over sine of angle B. Then once you cross multiply them, then we get 12 sine of 30 times radical 34 sine of B. Then you can easily see that the sine of B, by calculating this value, has to be equal to, in fact, 1.029, but you realize that sine of B cannot be greater than 1, or so therefore this is not possible. That means we cannot create any triangle. Number 24. As you can see from the first two multiplication, the values are the same except the sign in the middle. That means this is the difference of squares. So we get first term square minus the second term square. Now, if you have to square the the last perfect square, we end up getting 3 over 2x squared minus 2 times negative 3 over 2x times 1, and this portion becomes the expansion of this one. Then you will realize the first terms will cancel out because of the negative sign that you can see over here. And then if I have to rewrite it, then negative 1 and then 2 cancels out, so we get positive 3x and minus 1 because positive and negative. Then we end up getting 3x minus 2 becomes our answer, which is choice 4. Alright, let's look at the next question. Number 25. This one is, in fact, we just have to put that into the list. So first values in the L1 and then frequencies in L2. Then you get to realize that and then you do one varstat, L1 comma L2, or one varstat, making sure that L2 is in the frequency. Then we end up getting Q3 minus Q1 simply becomes 12 minus 7, which is 5, becomes our interquartile range. Alright, let's look at number 26. Now, in order for you to convert the radian, the length of the arc with the radian and the radius is equal to, we just have to simply multiply them. 18 times 2 pi over 5. because length of the arc is the radius times the measure of the central angle in radian measures. So once we do that, then we get 36 pi over 5, which is about 22.6. So therefore choice 2 becomes the answer. Number 27. So we're going to plug in a plus 1 in place of x. Then what do we end up getting? 4 times a plus 1 square and minus a plus 1 plus 1. Now all we have to do is expand them. Then when you expand a plus 1 square, then we get this one minus a minus 1 plus 1. Then those last two terms cancels out. So as I distribute 4 and then combine that with negative a, then we'll end up getting something like this. It's negative 4a squared and becomes plus 7a plus 4, which is choice 4. Number 28. The fact that they varies inversely, that means we get to multiply them and then their products are equal to each other. So p times q must be equal to p prime times q prime. The first set of values of p and q is 25 and 6. So when I multiply them, that should be equal to 30 times q. Then we get to realize 150 equals 30q. Then obviously q then would be equal to 5. Alright, let's look at the next question. Number 26. So when we have complex fractions such as this one, it will be beneficial for us to factor everything out and then see how we can simplify first. So I'm writing down the factors form here, 6 minus x and 6 plus x for the difference of the square on the top. And x plus 6, I'm just rewriting them 2 times. And on the denominator we have x minus 3, but the factored form of the denominator here we get x plus 6 and x minus 3. Then we can see there's some cancellation going on already now. And what's remaining is x plus 6. So we're going to multiply x plus 6 on the top and bottom to get rid of the denominators. Then x plus 6 cancels out here. Only thing that's left is 6 minus x. And that becomes our answer. Alright, let's look at number 30. So we want to find out the value of x. Since our x is on the exponent, we can use logarithm to cancel out the bases. Or in this case, we'll use ln, because ln of e is equal to 1. So then we end up getting something like this. And then 4x by the power rule and ln of e, we know that to be equal to 1 is equal to ln of 12. Then x must be equal to ln of 12 divided by 4. Now, and that's approximately equal to 0.62 blah 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 blah. So to the nearest hundredth will be 0.62. Alright. Number 31. We want to do this one into the degree measures. So then 5 pi over 11 will be multiplied by 180 over pi. Then once I do this one, you can see that we'll end up getting 900 over 11 degrees. Now, that's about 81.81, so forth and so on. Then we know that that's equal to 81 degrees. But 0.8182, this portion, if you multiply that fraction of a degree, turning that into minutes is you just have to multiply that by 60. Then you will get 49 minutes. That becomes our answer. Number 32. So here we have, this is the binomial probability. Since we have out of 6, we are looking for 5 of them. So that's why we start with 65. A probability of success was 2/5, so we get 2/5, and then raised by the 5 exponent. And then the last one is the other portion of the probability, which will be 3 out of 5. And then exponent will be 1. So once you calculate this one, then we end up getting 576 over 15, 625, and that becomes our answer. Now, in this case, I just have to distribute 2xi, 2x to the I and negative 4i square. Then my first term becomes 2xi squared. Next one is negative I to the third power times x. So then I squared is equal to negative 1, so that's why we get negative 2x. I to the third power is negative I, so that's why negative becomes positive 8ix. Only because they told us to put it as a plus bi form, and then if I had to follow that format, then I would have gotten the answer that looks like this. Alright, let's look at the next question, number 34. Now, on the test normal distribution of the score, 57 falls 1 standard deviation below the mean. So that means 57 would have been around here. And then 81 is 2 standard deviation above the mean. Then that's what we end up getting. So we have 1 standard deviation, 2, and 3. So between 57 and 81 is 3 standard deviations away. Determine the mean score. Then how would you determine it? So difference between 81 and 57 was in fact equal to 24. Now, but we once you divide that by 3, because that's the difference of 3 standard deviation, we know that each standard deviation will be equal to 8. So then when you add 8 from 57, then we get 65. So 65 must be our mean. Alright. Number 35, the area of the parallelogram is in fact given, and two sides are 32 and then 46, and we're looking for the angle between them. Then we know the formula of the area of the parallelogram is equal to multiplying those two sides times sine of the angle between them. Now, then once you calculate this one, we get to realize that the value of angle x is equal to 23.8. Simply, we just have to divide both sides by this one, product of 32 and then 46. Whatever value you end up getting, you can get arc sine, meaning second sine up on your calculator, to figure out the value of the angle. Alright, let's look at number 36. First row will be placed in L1, and the second one will be L2. And notice that it is years after 1990. Once you do that, then you plug in the exponential regression, then your equation will be something like this. Now, but the second part of the question is we have to predict the number when the year is 2002. 2002 in fact is equal to 12 years after 1990. So in place of x, we're gonna just plug in 12 and then put that into your calculator. Then we'll end up getting something like this, 40.79. But they wanted to put it to the nearest integer, so we end up getting 41 would be the answer. Let's look at number 47. They want us to get the next three terms. All we have to do is actually just plug in the values. That's it. So then here, a sub 1 is equal to 2. Then what is a sub 2? Based upon the recursive formula that's given here, is equal to 3 times the previous term to the negative 2 power. So then we get 3 times 2 to the negative 2 power. We end up getting 3/4. And a sub 3 can be done exactly the same way compared to a sub 2. Then we end up getting, that's right, we get 16/3. So then our final value, a sub 4, would have been based upon a sub 3. So then here we get 16/3 to the negative 2 power. That means 3 times 9/256. Once we end up getting that, we get 27/256. That becomes our final answer. Now, number 38, they want us to find the equation of the graph, then first step would have been finding the midline. Where's the midline? It's around when y equals 1, and then from there we know that we are going up and down by 3 units. So then that's how we know we have to start with the y equals 3 cosine of x. Now, but the thing is, notice that we have period is equal to pi from amount of duration that covers one cycle. So then we end up getting 2 pi over pi, because that's how we figure out the frequency. Frequency is 2 pi over period. Then we get 2, so that's why we get cosine of 2x. Lastly, we just have to attach the midline, which is plus 1. And that becomes our answer. Number 39 here. So here we have original rectangular deck is 14 by 22, but we like to increase them by the same measure of length and width. So then we're gonna just simply assume that it is equal to x. So on both sides we get 22 plus x times 14.x would have been equal to 800 square feet. That would be the maximum possible. So when I multiply things out on the left side, we get x squared plus 36x and then plus 308 is equal to 800. So bringing everything onto one side, then we end up getting x squared plus 36x and then minus 492. It's quite ugly number, so we're just going to use the quadratic formula here. And then we're going to realize two values once I'm putting them into the calculator. Then one value is negative 46.6 and the other value is 10.6. And negative values, we will not be accepting it in the physical dimension here. We can subtract negative 46. On the other hand, the second one would have been then is equal to 10.6. Once I have done that, then my maximum whole feet would have been equal to 10. So 10 would have been our final answer. Okay, with this one, I'm going to stop. I'll see you later. Bye-bye.